Yo, what's up, everybody? Welcome back. Today we are working on our map, and today's task is trying to figure out how to plan a bus route. So, this is a map of Vancouver. All of these red dots are from yesterday's stream, and these are a bunch of bus stops in Vancouver. It's not all of them, but it's most of them. What we were trying to do is we were trying to replace Google Maps because it makes me angry. Right? I'm at my house and my friends say, let's go to this bar, and I'm like, I want to go to the bar, and I ask Google Maps like, how do I get there? And I type it into my phone, and it says like, take this bus and then take that bus and then take that bus, and it gives me like a really like what I would call like a poor route with several transfers. I go, hey, like I can like that first bus is gonna take me like 10 blocks. Like I can walk 10 blocks, and then I don't have the cost of like missing a transfer and having to wait 15 minutes at the bus stop, blah blah blah. So I want to be able to like plan my bus routes the way I want them to be planned, which is essentially like I want something that's like fast and consistent. Maybe some days I'm more willing to walk than other days. Maybe some days I don't want to get on the bus at all. Maybe sometimes it's raining and I would rather wait for the bus underneath like an awning instead of walking outside and getting soaked, right? So there's all these like tunables that I want to be able to set. And so we're working on a path planner right now. If I hit start path planning, we have something. I don't know. It's kind of hard to see because it's the same color as the stops, but there's like a red line going through the city that kind of like tracks my cursor here. So we have like some form of a star path planning. On a separate branch, we have some like cost adjustments where we can say like, hey, I want to avoid walking on busy streets. I want to ride my bike and go on bike routes. Like there's all sorts of like tunables. We can like to look at the attributes of a given street. So here I can look at this one. It says like, hey, this is like highway service, which means alley. You can say like, I'd prefer not to walk down alleys. I'd prefer to walk on sidewalks, right? So you can go over here and you're like, oh, this is a sidewalk. I'd prefer to walk on sidewalks. Stuff like that. And yeah, so the plan for the day is to try to like start working towards integrating this with bus routes. Yesterday we pulled in a bunch of bus route data, or 2 days ago, I guess, from Vancouver's TransLink, and they give us this like chunk of CSVs in this like GTFS format or something. And if what we discovered was we have something that's like, you have like your bus stops, right? So this is like, you're in your city. These are individual points where you can get on and off the bus. There are bus routes, which are kind of like an abstract concept, but it's like what you would think of. You're going to get on the bus, and you know that the 25 goes down this street and this street, right? There are stop times which link. There are trips. So if say there's like a bus that goes down here, but there's another bus that like keeps going this way. One bus trip is basically like one movement from one end to the other end. So the bus starts here and he goes all the way over here and then he stops. That's one trip. Now, a bus runs many times in a day, so the bus is going to take several trips along that route. And the way these things get all tied together is that there are times listed for each of these stops. They say, hey, this is going to happen at like 1 o'clock and 2 o'clock. And the thing that coming at 1 o'clock is for trip ID like 5, and this is trip ID 5, which goes along route like 1, right? So there's like kind of like 4 layers of information here that we have to work through. And so if the goal for today is to try to basically make it so that we can like see a bus route on the map, maybe I want to like get to the point where we can hover over like a line between these two stops, and it'll tell us like, hey, this is a bus route for both like the 33 and the 25, and this is like some metadata about those things. That would be like a good spot to get to. So if we want to do that, we have to somehow go stop times to trips to routes and then draw those lines. And what's kind of interesting here is that like some buses have different routes at different times of the day. Like I know for sure that the 22 goes from like downtown up, I think like McDonald Street or something, to over here, and I'm pretty sure that at some point in the day it just stops going all the way to the end, right? So there's like something interesting there about like trips and routes aren't necessarily mapped one-to-one, but they're like kind of close. And if we want to show like a static map, I'm not really sure what we're gonna do there, so we have to figure that stuff out. But yeah, that's the plan. That's fine. We want to make links. We want to see the links. We want to see information. And if we have that, then we can get to the point where we can start planning, doing some like rudimentary planning over the bus area. So probably what we'll do is we might say like, hey, I'm going to add like a bus trait. And then we'll like, if we see the bus trait, we assume that that's a faster thing or something. We probably won't get into stop times right now, because I think like our cost function eventually will have to be like, you'll have to say like to get onto the bus route, you're going to have to wait for some amount of time. And so we're gonna have to like make sure that our like path planning algorithm is in like units of time instead of distance and stuff, which is not right now. So we'll have to figure that out eventually, but I think that we won't get that far today. Today's plan is just let's fucking look at the bus routes. Let's look at the bus routes. But before we do that, generation of this data is really slow right now. What we do is we like look at all of these CSVs and we say like, hey, we can import those into like an SQLite database, which is great, and then we can use like SQL queries to quickly pull out the stuff that we care about. Except that the SQL queries are running really slow right now. So before we get into like updating the data and stuff, we're going to have to make it so that it doesn't take like fucking forever to work with the data. So that's step one. Step one. So the way we do this is we have like this like gen database script that just says like, hey, run this like SQLite script on this thing, which calls create trips db. And he says like, hey, I want to import these things as tables. So they take like the CSV, he reads the header, makes those the headers for the given table, and then he then we can like query those tables, and we query those tables from this like SQLite wrapper in Zig. So I think if I remember correctly, this is what's taking forever. Is this like fucking like mega query of like, give me all of the stops associated with this route. So I think we can do like SQLite browser on test DB. I'm pretty sure this is where I saw that this is shit. So I think we have, let's like look for a route that maybe we recognize. So 41st Avenue R4. Maybe I think that one has not that many stops. Maybe I want like the 25. 6627. Let's use 6627 as our example. So we replace this with 6627. We hit play. And we do see that that took like fucking like 600 milliseconds to just get all of the stops for the 25. Not acceptable. Completely unacceptable. And on my other account, I did have to play with this a little bit to get the thumbnail for the last video up. And I'm pretty sure what I did there was I just started like hucking indexes at everything, right? So I know that like looking at this query, if we can kind of like break it up a little bit. Oh my God. Here we press enter. Here we press enter here, and then enter here and here. Here we go. So we can see that there's like a few things that we're like indexing on, right? We're looking for stop ID from the stop times table equals stop ID from the stops table. So these two things probably have to be equivalent. Everything in all of our data is text right now. And so I'm pretty sure that comparing numbers is faster than comparing text. If we look here, everything says text. So I think that what I want to do is I want to take all of these IDs that we know are going to be numbers and like force them to be numbers. And then we can add some indexes for the stuff that we're like comparing on, right? So we're looking for like, we know that we're going to be indexing on route ID. We know we're indexing on stop ID for these. And we know that we're indexing on trip ID as well. So we can just like throw some indexes at all of those and then do some like casts, which I don't remember what to do. But I think it's like SQLite change column type. He will tell us. He will tell us. But do you remember that column types aren't rigid, blah, blah, blah. I thought that there was like update this, set this to that. Yeah. This looks like what I did. And this sounds right to me. That seems reasonable. So we'll just go into our generator script. Create. And then we want to do like, what was it? Update table. Update stops. Set stops is equal to cast stops stop ID. So set stop ID as integer. And if we do this for like stop times and trips and routes, and I think probably trips route ID. I think we want all of these. We need to get the thing right. So this is stop ID still. This is trip ID. This is route ID and route ID. I think this should be faster, but we can find out. We can find out. So we were at like 600 milliseconds last time. So if we just do that, we would be interesting to see What was it? It was 6627, I think, was what we were doing. That's way fucking slower, which is really funny. So we actually just made everything worse. But it's possible that I got the route ID wrong. So the 25 was 6627, which is what we posted. So we just made everything worse by doing that. So we shouldn't have done whatever the fuck we just did, I guess, which is kind of funny. I thought that for sure making everything integers would be faster. But I guess not. If we don't do this, let's just confirm. Oh, wait, no, it's taking longer probably because we're not clearing the database before we do this. We'll probably just have everything in there twice. So let's do this. Try again. Wait, one second. 6627. Okay, let's try that. Okay. So this just had no effect. Still 605 milliseconds, which makes sense when people are like, when those people on the internet were like, you do, like, they're not really typed anyway, so it doesn't really matter. I guess that does make sense. Okay, let's try the other thing that I wanted to try, which was just like fucking huck indexes at it. So we know that we're looking at, what is it? Add index SQLite, which basically says like, you can imagine it as like you have a hash map, right? And you have like a hash map to a bunch of values. But like maybe one of like how to say this, right? You have like A and B, like key A and key B, right? You can imagine if you had a hash map of things from A to B, this is fast, right? But if you want to go from B to A, you have no way to like do that without like walking every entry in B and like looking for the one that goes back. And that's how you would like index by B. So if you say to SQLite like, hey, this is my key and these are my values, then like you can still do a query on key B, but it doesn't do the right thing. What you can do is you can say, hey, just so you know, SQLite, I'm going to be indexing on key B sometimes. And what it will do is it'll make like a second hash map that's like key B to key A. I think. I don't really know. But this is like my internal understanding. And so if you have like in here you have like val C or something, like basically now you can like find value C from either B or A, but there's like extra cost to maintaining the index. Yeah. So I think that that's what I want. I just want to like show me somewhere. How do I make this thing? Drop index. I want create index. Here we go. Create index name on table name. Okay. Did you alter the content or just the content? I kind of assumed that would do it automatically, but I guess maybe that's not right. It could be that I just did nothing here. That's very possible. Okay. Stop ID on stop times stop ID on stop times. I want stop ID. And I guess it's kind of, this is kind of indicating that I can have multiple columns that I index on. So here I just want to make like stop times index, I guess. And I'm going to look at stop ID and, is that it? Trip ID? What is in stop times? Google Transit stop times. What's in here? Stop ID, trip ID. So I want both of these. Okay. Then we have stops index, and this is just stop ID, I think. If we look at our query, we can probably check. Plus DB. So we're looking at stops, stop time, stop ID, stop ID, stop times trip ID, and trips trip ID. Trips. This is stops. Trips index is trips trip ID, and we have to match this to the route ID, and then we have route ID. Okay. Let's see if that speeds us the fuck up. Already table name routes, route index. Much better. Okay. Throw this in here. Fuck. Where's our fucking query? Plus DB. This thing. And it was 6627. Fucking run that shit. I thought that when I tried this the other day, it made it way fucking faster. Which kind of makes me think that I've done something wrong here. Because I got this down to like 7 milliseconds when I tried this before. Did I not run GenDB? Did I not save, create? Okay, I did. Oh, and we do. Oh no, this isn't the indexes. Indices 0, so we didn't run it. Am I fucking high? Okay, indices here. We do have. Oh, maybe I'm not supposed to do it like this. Maybe this is like a dual key thing. Like if I do this and then do this, does it behave differently? I don't know because I don't know what I'm doing, but you never know. Like, let's just see if I do this, if it behaves differently. Let's just see. I think that you're not supposed to just fucking blindly huck indexes at stuff. I think I've heard that makes you like a fucking stupid idiot. But I'm a stupid idiot. So, what you gonna do? You know? 667. Oh yeah, there we go. There we go, baby. Look at that little 2 millisecond query down from like, what was it, like 600? So we're fucking blazing fast now. We're fucking moving. Absolutely moving. And also, like, for us, kind of just like blindly throwing indexes and stuff is fine because we're never actually modifying the data. We're just using this as like a view into existing data. So like the cost of this is like 0. Which is pretty sick for us. Pretty sick for us. Okay, so now we should be able to go into make site. And we have like get all stops. This thing before was only going through the first 100. We should be able to do everything now. And it should fucking go zoom, zoom, zoomy, zoomy. You know? So let's see. Let's see. Give him a sec. Now I guess it's kind of hard to know because the rest of this is kind of slow, but like before stream, for the people who are here, we were seeing it kind of like go like bonk, 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 and we should see this guy. Okay, yeah, that's like manageable time. We can like that's usable. That's usable. And now if we refresh here, I guess we have to run the server. We do have to run our HTTP server if we want the HTTP to be served. That is true. And we have all the bus stops now. Look at that. Look at that. That's every bus stop. Let's go, baby. Let's go. A bunch off screen. That's fine. Okay. Cool, cool, cool. So that's fixed. We are ready to actually make some improvements. I guess there is no 17 minutes and 60 seconds. That becomes 18 minutes if you think about it. Are you getting these from API? We got these from TransLink data. We got it from maybe like TransLink API. I think we got it from, where the fuck am I? I feel like it was from somewhere here. Statics, GTFS, stat data. We got it from here. From here. We clicked this button, and it gave us a little zip file. But is it giving you all bus lines, bus stops? Yes. Yeah. So this gave us this zip file has all of the bus stops in Vancouver as well as all of the times for this month. There's like this like calendar thing that we didn't look at. Calendar. So I don't know like what the fuck is going on with these things, but I imagine that there are like some days where some trips are available and some days where they're not. Service ID, date, exception type. Yeah. So I think that here what they're kind of saying is like, hey, some things are not going to be running on some days. Anyways, so we have everything. Okay, let's figure out how to tie them together. Where are we? Here. Okay, so I guess what do we want even? I don't even really know. Oh, that's so cool. Does it come with the layout or did you build it? I can't relate. All it gives us the data. The map, like we made this like map by hand. This is our map. This is our map. So like all of the stuff underneath, all of these lines and stuff, these are from OpenStreetMaps. the only thing that like the transit data goes is these where the like the latitude and longitude of these red dots, essentially. Okay, so what do we if we want to link them together? Like we said at the beginning, we have stops, we have trips, and we have routes. Trips are individual runs on a route, kind of. Stops are linked together by trips with specific stop times. So, like, at 4 o'clock, we're going to run a bus between stop ID 1 and 2. Now, if we want to say, hey, we want to look at all the routes, we must say, maybe we go through, for now, maybe we take one trip per route. So we look at all of the routes. Maybe we want the longest trip per route, right? If like maybe like the bus doesn't run the full length of the route at the end of the day, like because it's late and nobody goes over there, maybe. But for now, we'll just maybe we'll pick one trip per route. And we pull out the stop times, which is kind of what we're doing right now, actually. But that's already what we're doing. We are pulling out. Let's look at our like SQL query. It's like this fucking disaster. So this is basically saying like, okay, can we like make it a zig string with multiple lines like this, and we can kind of start breaking it up. So it's select this from this. So this is we are getting the longitude and latitude from stop times, but we are joining in stops. So the stop ID is equal to stop ID. Okay, that's fine. That's fine. So we are basically stop times gives us times. This gives us locations. Fine. Now this is the interesting part. We only extract for whatever the fuck this says. So we look for the first trip for a given route. Well, I guess like it's kind of undefined order. We are getting one trip for a given route. Select trip ID from trips where trip route ID is equal to the number. Okay. And then we sort them by stop sequence. So this is kind of like the order in which a bus will go through the different stops. So I guess the order that we get these things in already defines like a connections. Okay. That makes sense to me. So when we call get stops, we call this in like get all stops. So we iterate over every single route and we return a double vector of points. Okay, this is making sense. This makes sense. So we have probably everything we need right now to draw the lines. That should be easily doable. So the way that like our data preprocessing works is like pretty much just heavily influenced by OpenStreetMaps. So the OpenStreetMaps data has like nodes, boom, 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 and it has ways, right? So if these two things are connected and these two things are connected, we have like a way that is like 0 to 1 and like another way that's 2 to 3. In OpenStreetMaps, all of this stuff came in as like this giant blob of XML data, and we basically convert it so that we have a big buffer of node locations. So if this is at like 0, 0, and this is like 2, 2 or something over here, right? We're gonna have like this is at 0, 0, then this is at like 0, 1, this is at like 0, 2, and this is at like 2, 2 or something, right? This is like what our like node data buffer looks like. And then to define these ways, we kind of put them in another buffer that says 0, 1, FF, 2, 3, FF. So what this says is, hey, 0 points to this, 1 points to this, 2 points to this, and 3 points to this. And so these FFs basically say like, hey, start drawing a new line. And so we basically just like kind of like draw connections between like sequences of nodes, and we can like kind of like mix them in any order we want. The reason we do it this way is because you can with OpenGL, you can just like upload. If you say, hey, OpenGL, take this buffer and call that buffer 0, and take this and call this like index buffer 0. OpenGL will automatically draw everything for us. So if we just like take these shit and we shove it into OpenGL, we get this like the white map for free. And so all we should have to do here is if we want to connect the bus data stuff is we have the nodes in this data format already. We just kind of like shoved them in after all of the OpenStreetMap data. All we have to do is like make these connections, which should be pretty doable. Pretty doable. So make site. Make site somewhere we push the nodes for the buses. Okay. We push them with like IDs, because like the piece that I didn't really fill in here is that like this might have node ID like 9632 and this might have node ID like 1234, but we need to convert these like IDs into indexes into our buffer for like this stuff to work correctly. And so we track the ID of each thing we push in. Now, what's kind of weird here is that we have no guarantee that like there's no collision between OpenStreetMap's IDs and TransLink IDs. So before we just kind of said fuck it, we'll just kind of use -1 for every TransLink ID and we won't worry about it. But now if we want to draw between them, we kind of do need to think about it a little bit. A little bit. But I guess when we say get all stops, this is losing information about which route is which. I don't know if we really want that. I think we kind of want to know which route is which so that later when we want to tack on information like this is part of the 25 bus route, we need to be able to tie that information back somehow. So this has to say like we need to return like route info, I guess. And it's gonna have like a route ID as well as a like path. Right? Like this. And that means that this can now return route info like this. Then for each of these we say return. No, here this now needs to get a array list of route infos. That makes sense. And then here we don't append this. We say ret stops is equal to this. And then we append a thing that says the route ID is the row and the stops path is ret stops there. So this, we'll call this path, I guess. Match the names up. Okay, so now in make site, we iterate these things, and now we have this for each. This is going to be routes, I guess, is what we got here. So stops, whatever we call this. This is going to be called routes now. For this, we push the nodes, and we're going to push the nodes. Maybe we'll kind of like store these like two concepts as like, we're going to say like we have OpenStreetMap nodes that we're pushing as well as TransLink nodes. Yeah. That makes sense. So we can kind of store like node ID to index. What is this? Node ID index map. So we say, hey, you got an I64. We're giving it back an index, and this is gonna be like OSM nodes as well as like I don't want to call it TransLink. I think it's GTFS nodes is kind of probably the more correct name here. Was it FS? GTFS, yeah. And so here we're gonna say one of these things is pushing OSM node, which I think is fine. But then we need to make sure that like all of the generic stuff here gets put somewhere. I don't know where yet. We'll figure it out. So we're gonna say like push GTFS node as well is going to look very, very similar. Very similar. I guess we're gonna have like push node impl, and it's again gonna look very similar. It's just this is just not gonna push into these like index maps. So he's gonna do everything that this does. Everything it can do better. I don't know why we're catch returning somewhere. Oh, because if we see the same node ID, it doesn't count, I guess. Sure. I don't know why we have it that way, but oh, because I think that we might push things twice in some conditions. I can't remember why that would be, but it's possible. And so here we're just going to say we write the thing. We write the thing like this. But then we return back the push index. So maybe we do a defer here so that we can say return self num push nodes like this. There we go. And then this guy's going to say, hey, I'm going to push that node impl, please. Push node impl with node ID lon and lat. Except now all he's going to do is going to take the response. He's going to be like, IDX is this, and then he's going to put this into this. Boom. Simple, simple, simple. And I think this should be try, to be honest. I don't know why. I've disagreed with my previous self here. Now this is going to do the same thing, and we just have to say which ones we're pushing to. So this is OSM, and this is GTFS. Boom. Okay. He's probably doesn't using node ID here. That makes sense because he's not stashing that shit. This is purely writing the data. And then here, when we push way nodes, this is going to be like push OSM way. We're going to call this. And this comes from OSM nodes. Boom. And I guess we are going to do, I think we can just full copy paste this function for GTFS. He still writes this like separator for different lines, and he just pushes from this, but everything else is the same. And like technically there's like a little bit of duplication here, but I don't really see how we would avoid this. Like I think splitting out a function here doesn't even help, to be honest. Okay, so now everything will break for sure. So he's mad because map data writer gets OSM nodes as well as GTFS nodes. His deinit certainly needs to say, I'm going to deinit both those things. Inline function. I mean, I just don't think it helps. Like, I think that like there's no, like, I don't think it doesn't make things simpler. I think that like the number of functions that we have there is already the minimum like number of lines, I guess. Or at least it's not really worth going farther into it. So here we are looking through the XML parser stuff. So this is push OSM node. Okay. He's mad because of something. This is supposed to be IDX. No. Right, this is a try. There is no try, just succeed. Then for this, we are pushing GTFS node from the bus stuff. Then this is push OSM way. Cool. And then we can just kind of do the same thing here where we say push GTFS way. But you do this based off of something else. For routes, we have a route. And here we actually want to push the node with the given stop ID. Ooh. Okay, so maybe what we've done here is like maybe a little stupid. Get all stops. We might want to return like a flat list of stops, but maybe not. We'll see. Okay, so when we push the OpenStreetMaps nodes, we do them in order of how they're connected, because that like heavily improves the performance of our search algorithm. Because like the way that the search algorithm works is it like looks at one node and then it looks at all of the neighbors of that node, and says like, oh, should I go that way, that way, that way, or that way? And so if the nodes that are connected to each other are like sequential in memory, they will already be in cache, which is like makes it like way faster. So we might want to do the same thing here for the GTFS nodes, which we kind of are just we're doing automatically because we're pushing them in order of routes. But we should make sure that since we're iterating by route here, we might end up seeing that like the same stop index or the same like stop ID might be like implemented as like two separate nodes here. So I think that when we like, how do I? Maybe I'll draw this out somewhere. So like, you know, you're going on the street. You have like a bus that comes down here, 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 and then there's like, you know, one of the buses like turns off and goes this way. But they both stop here. So this is like an example of this in Vancouver is like the 16 and the 25. So here, this stop takes 16 and 25. This takes 16 and 25, but this is just 16 and this is 25. So the way that we've done this right now, this is actually going to be one node for 16 and one node for 25, just like kind of stacked on top of each other, which is no good. No good. So I think that when we are pushing these like nodes, we actually want like stop IDs to be here. And then we want to make sure that like, I guess we kind of do the same thing here where we were kind of tracking externally, like if we've seen this node ID before. And I'm kind of thinking that this should like live in the data writer, maybe. I guess data writer being I write data kind of makes it seem like that's not the case. So let's do this. We'll say this is a scene OSM nodes. And then we can kind of do a scene GTFS nodes like this. And then we'll just kind of do the same thing here where we say, hey, did we like fucking see this thing already? Did we see this thing already? So this is going to be scene GTFS nodes. We're going to push the stop ID, which doesn't exist yet. We'll figure that out in a second. Okay. Okay. So far, this is making sense. So here, I think what's going to end up making sense is we are going to have to store the IDs of all the stops adjacent to the path. So where the fuck do we bus DB? Bus DB. Okay. So when we get all stops, this is going to give us the route ID, the path, and the stop IDs. Now, you could argue that you should do, you know, stop. And you would have like const stop is equal to struct, and the struct has like lat, lon, and ID. But the reason I'm not doing it this way is because the API to push nodes in make site takes in, or push ways, I should say, takes in a list of IDs, right? And so I would like to be able to keep that as so that I have the stop IDs like this as like a buffer that I like have just immediately, if that makes sense. So this is gonna be point. I guess maybe we make these const. Fuck it. And then here when we get all stops, we have the path, and the stop IDs is equal to stop IDs. Okay, so now I have to like get the stop IDs somehow. So like get stops. This is gonna return. Right now he gives us like points, but I guess we want the stop ID as well. Okay. Which means that this is gonna have to return like stop. Stop sequence, we'll call it. And he's gonna have like the points as a point. And then he's gonna have the IDs as I-64s. Okay, which means that here he's going to have ret points as well as ret IDs. Okay. Which means that here we're gonna like do this is ret points, and then we're also gonna have to do ret IDs is the ID. Stop ID, which we don't have right now, but we can get that very easily because we added it to the outputs here. So it's just get column 1. This is going to be stop ID. We don't have to extract text here. We can just directly extract an int64 from column 2 of this statement. Okay. Yep. And then here we just say like this, boom. And then here we say that we are returning our stop sequence. Okay, like this, boom, 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 boom. So here now we say return points is equal to this, and stops is equal to try ret stop ret IDs. Boom. Boom, boom, boom. Boom, 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 boom. Like that. Boom. Okay. Which means here now we have sequence. This is sequence.path and sequence.stop IDs. Okay. I knew you were trouble. No field name stops. This is stop IDs. Really? What is it? It's IDs. Fine. No field name path. So this is what is it then? Points, I guess, is what we called it. No field name stop IDs. This IDs. Boom, boom. And then here, this is for 0 route path len. The stop ID is the route stop ID ZI, and this is the stop is the route path I. Boom. And then this is stop ID is equal to this. Boom, 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 boom. All right. So now that we've done that, this is mad about something. Push GTF this way, so this is going to be stop IDs. And then maybe that works. Maybe. I guess we have to make the site. Make site. We do need to export new data if we want new data. If you think about it. If you want the data, you want the data. All right. Failed to get stop points. Failed to prepare get stop point statement. What did I do wrong? I think I put an extra comma there that I shouldn't have. Little extra comma. But we'll see. If that's not it, we'll have to try a little harder. But if we can avoid trying, then that's great. Looks like we're chilling. Hell yeah, baby. Hell yeah. All right. Let's run our server. Am I like... There we go. Yeah, okay. Yeah, so this is for sure drawing a line between these two stops. I guess that's kind of indicating that this is fucked. Right? Like, the distance between two stops is not a straight line. But I guess that's okay because we already have, like, the metric of time between these things. So it actually does kind of make sense. Like, these things in terms of, like, graph theory are just connected by an edge like this. It's just the edge cost will depend on something. I almost want to color like the bus stop route like a different color. I almost want to make it like blue or something. Yeah. And then what the fuck is going on here? Oh, I see. So these guys both come from this stop. I see. I see. I wonder if we have the capability of doing that easily. So right now we have like color is by way. So we have like our like data, which is like I'm at 0, 0, 0, 1, 0, 2. These are our nodes, which are paired like this. Then we have ways. So what's going to happen here is like all of the bus starts here. And we're going to have like more nodes. And then the same thing's going to happen with like our ways. We're going to have like 0 to 1 with an XF in the middle. And then like 0 to 2 and a 0xFF. And then here we can say like bus here, and we'll have like the same thing with lines connecting buses. Now, if we want to draw these in different colors, we have to draw in different colors like in this thing. So we're going to say like we'll draw this set first, then this set second in like a different color, which means that we have to keep track of like where the bus connection, like the ways, like the ways that things are linked together, which ones of these links are for buses and which ones are for streets. I guess we have to do. Or we could tag. That's like one option. One option is these are just like two separate graphs almost. Another option is that like we have like traits and we can like tag these with all of these ways with like metadata that say they're part of a bus, a bus route, which we're gonna have to do eventually anyways. But for now, I'm gonna just draw them separately. Draw them separately seems easier. So the way that we can do that is we can basically just say, hey, at some point, we are going to push all this stuff. We'll say right here, maybe we will say, we will keep track of like num pushed ways. Okay. Then every time we push one of these, we'll say self num pushed ways plus equals 1, which I guess kind of has to get copy pasted here, which is like a little bit odd now. Now you could probably argue that there's something to be split out here, but like the split out would kind of suck ass. The split out is like what? Like you would have to like convert the node ID list to a node index list. So you would like split out an iterator. I don't want to do that. I'm not going to do that. So I'm just going to, that's too much work. Too much work. Okay, so here we'll just say const end. We'll call this bus way start is equal to the data writer num pushed ways there. Then here we'll say, hey, bus way start index is bus way start. And then that means that metadata needs a bus way start. Okay. Why is he mad? How come it worked for one but not the other? Did I? Oh, I int cast it here. Okay, sure. I will int cast this as well then, if I must, sir. It's fine. That is fine. Okay, so now we know where the like ways for the buses start, which means that we can go into our rendering code. And we have like function render somewhere, and here he just says like what? Somewhere he like renders the whole map. Here, I guess, probably. Yeah, so he just renders all line segments. And so I guess we're kind of saying, like, bitch, don't render them all. That's kind of what we're saying. We're kind of saying, like, we're just saying that we have, like, street segments and bus segments, I guess. Right? That's kind of what we're saying we want. So we're kind of saying, like, hey, do this. Then start from num bus segments and draw. No, this is, sorry, num street segments. We're saying, like, start from num street segments, but draw bus segments. That's kind of what we're saying. And we're going to say, like, hey, draw those in blue. I guess. I don't fucking know, man. Seems kind of reasonable. Seems kind of reasonable, which means that, like, when we construct this thing, we need, like, num. We're going to need to say, like, we're going to need to construct this thing with some metadata, I guess. So app zig renderer init. So here, I guess we kind of say, I guess we'll call this, like, metadata bus way start index. We'll pass in here directly, which kind of means here he takes in, like, a bus street split index is like this, which means that these become, like, U32s, I guess. Okay. And then here we say that our num street segments is the split here. And then the num bus segments, num bus segments is whatever the fuck we had there before, index data.len minus bus street split index. I guess. I don't know, man. I guess. It's like a maybe. I guess we probably have to make the site again so that we get the split index in part of the metadata. Needs to get in that metadata, baby. Okay. He's cooking. He's cooking the data up. Cooking the data up. And then we should be able to run this. And what I'm hoping to see is a bunch of blue lines for the bus route stuff. Instead, I'm seeing just an absolute fucking fucked everything. That's what I'm seeing instead. So we did something fucking stupid. GL draw elements. What does this do? This is offset and count. Okay. So here, num street segments from offset 0. Then bus segments from offset street segments. That makes sense to me so far. We could maybe look at I guess before we do get crazy here, can we go kind of undo the changes that we made on the renderer side? Let's just kind of, well, I want them to stay here. But let's maybe make the rendering stuff work okay. So if we say here, num bus street segments plus num bus segments, then we should, this should draw everything, and we comment this out, and it should not draw anything. So this should just go back to what it looked like before we made these changes, I think. Which it did, so that's good. That's good. So we have the data's all here. The data's all here. Now if we say, hey, fuck off bus segments, let's not draw the bus lines. Is this where it starts to fucking fall over? Yes. Yes, it is. I guess I should also fucking open this so that the cache is disabled. So it just means that this num street segments thing is, like, just fucking set to a bad value. So this is coming from on init. we pass bus way start index. Oh, I'm an idiot. Uh, make site. So here we're saying like every time we push away, we say, hey, we pushed this many ways. But really what we want is we want number of push way indices. Right? So the mistake here is that we had like you have like a way that goes from here to here to here. Boom, boom. This is like 0, 1, 2, XF, F, right? Uh, this is like one way, but these are all each indices. And if we are asking OpenGL to draw the indices, then we want like this number, not this number, which is fair. Now there's a chance that we also want the other number. That's like very possible. We might want to we still might want to track this as like the number of pushed ways and then just convert back to the index. Right? Because if we're saying like at some point we're going to want to like interact with the graph from the CPU separately for like buses versus things, I guess like they're both kind of equivalent. They're equivalent. Let's see if it's easy to go back from what we have right now to the right thing. So here we have somewhere way lookup. And way lookup is something. This goes to ways, where ways is a way lookup. Way lookup has this, okay. How do we get like indices from this way? We do allow us to go back to an index range from this. So we could do like way lookup get this index. Hold on, we get there. And then like first bus way. And then we could do like first bus way index range given, I think it took in the index buffer, which is just split data index data. So we can say bus index buff index. And then we pass this here. I don't know why it's not auto-completing for me. I feel like this should be fine. And it is fine. So I don't know why it wasn't auto-completing. So now it looks like everything is rendered again. Good afternoon. What's up, two-step? What's up? And so now we can go back to trying to split the drawing of these. So we could say, hey, fucking draw me these bus segments, please, in blue. So if we did everything right, we should see blue lines connecting all of the bus stops. Which we are not. He is mad about this. Byte offset. Oh. He wants a byte offset. Really? So this is times 4, I guess. But the number of elements is not offset by 4? That's kind of confusing. But that looks like it's working. Right, we have blue lines between the red dots. And they are like off-grid as well, which makes sense. Right, so here we see that like this bus must go from... What the fuck? Hello? Oh, it goes all... Oh, it's this... it's this one. So there's a bus that goes straight from here to here. Probably through like this street over here. It must go like yeah. So this is the bus loop at the university. So each of these like serves as a different bus, and it's kind of fun. You can kind of see the connections for where they all go. So yeah, I guess this is probably the like express bus. Is this Vancouver? Yeah, Vancouver, Canada. So this is probably, I guess this is Broadway. So this is the 99. Yeah. So this is the express bus that goes down Broadway. He comes all the way over here, and then this is the Sasamat stop. This must be Sasamat. Sasamat. Yeah, nice. Nice. Okay. Cool. Coolio. I guess it kind of makes sense to keep showing the bus stops like this. That's not crazy. So I'm just trying to think how I want I mean they're too big right now, right? So maybe we kind of draw like some would say bussin'. Yeah, we're bussin'. Perfect. What's up, alcohol and Q? All right. Okay, so I guess we kind of have this like link bus stops together. And I guess let's do a quick like make it prettier a little bit. So I think all I want to do here is I guess I kind of want to scale the point size of the bus stops with zoom. I think that's what I want. That's like the core of why this is fucked, is because when I zoom out, it's just like this like red mass of shit. So we want to do something like when we render the bus stops, which is going to be an app.zig, we have function render. We first of all, let's draw them blue to match the links. I don't really like the like darkness that it is, so can we do like maybe like a little bit brighter blue, which I guess means that we just kind of like crank up this stuff a little bit. Actual bus route should be one of your possible pathfinding configurations prioritizing made routes. Actual bus. Yes. I think that we actually, though, I think that in terms of like the path planner, I think we actually don't care about the real physical route of the bus. I think all we're going to end up caring about is the time taken between stops, and we're going to have to convert all of our existing scores into like time space. I think that's what's going to end up happening, right? And then we can figure things out like when I get to this bus stop, it will have taken me n seconds. I left at this time, which means that the bus won't come for another n seconds. Then we can like add costs to like getting on and off the bus and stuff like that. And then these lines are kind of just for debugging purposes. True, only if you wanted to render the bus routes. Yeah, I wonder, does it give us that info? Shapes. Okay, that's interesting. So we do have the concept of shapes, which is separate from the concept of stops. And does that mean that trips have shapes associated with them? They do. They do. So here it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Ah, okay. So this column here is going. We could probably draw the routes on top. Now, do I want to do that right this second? So this has latitude, longitude. It would kind of be nice. But I guess like if we're to, it depends on like what the map is, right? Which is not well defined right now, right? If the map is supposed to be a map, then we would want to draw the routes, right? But if the map is supposed to be a debug visualization for the real purpose of planning a path, then we kind of want only lines between stops. Because then when I'm like, if I'm trying to like look at the algorithm and say, why did it pick this edge? Being able to look at the edge on the graph specifically and using that as like a way for me to be able to like say, oh, the cost of this node was this thing. I think that, or this like traversal was this thing. I think that kind of makes more sense. So I probably just won't ever draw the shapes. Probably. Maybe we will. It depends. Maybe we will want it to be pretty at some point, in which case we will. But for now, let's just leave it the way it is. Leave it the way it is. Didn't you want to scale the points? Yeah, Yeah, we're getting there. Calm down. Calm down. Calm yourself. So what the fuck am I trying to do? What am I trying to do? First, I wanted to change this to be a little brighter. Fix me dedupe color values, whatever. It's fine. For now, do I like it being 0.3, 0.3? Those are nicer. I mean, you could go even brighter, but I'm okay with that. That doesn't look like absolute total shit. It only looks like it looks kind of like I don't know how to explain this. But blue vomit is the vibe I get from this color. I don't know if anybody else is seeing that, but it feels like it's like if vomit was blue instead of green, which it isn't really. Like this is the color that vomit would be. I don't know why I think that. I think it's because like 20 years ago, I went on a road trip with my cousin, and she ate bubblegum ice cream and then threw it up. I think that's the only reason I think that. Because there's nothing about this color that actually says vomit. I'm just an idiot. And maybe I shouldn't just talk about vomit in the middle of my coding stream. Maybe people will be like, that's fucking gross. And they'd be right. Okay, what am I looking for? I'm trying to scale the points. Which means that in our vertex shader, we have a point size thing already. We actually have this. So we just need to basically recalculate this based off the zoom level. Zoom bigger for big number, big element. Big point, big number. Small point, small number. Small zoom, small number. Okay. So point size set bus point size times view state zoom. And then we just say bus point size is equal to like 0.1 or something. We'll see. I'm sure that's too big. Well, no, okay, so we know that zoom level 1.0 is fully zoomed out, and we know that the current size is 1.0. So that thing being 10 times smaller actually might be right. I think 0.1 actually might be like a really good guess. We will see. No. And also it's not scaling. So it's just not doing at anything. Or like maybe because I didn't have network tab open? No. Why is this not doing anything? Did I build? I did build. Here we set the point size to 10. Do we use this? We do. What the fuck then? Oh, this is only for the fucking. Oh, this is only for the lines. We don't want this for the lines. We want it for the fucking points. That makes a lot of sense. That makes a lot of sense. So where the fuck do we draw the points? Function render. Here. So this is bound render, not this. And then this is self-view state zoom. All right, let's try that. Let's try that. Okay. Oh, I want the things to get bigger when we get bigger. Okay, so why am I seeing nothing now? I feel like we should be able to find at some point, where's that bus loop? Over here. Like, at what zoom level do these start becoming visible? Never? Like, it feels like? Am I fucking stupid? If I set this like 5, just unconditionally 5, what does that look like? Those do stay unconditionally 5. Oh, the confusion I had was that, hold on. The confusion I had was that I thought that the existing point size was 1, but the existing point size was like fucking massive, so. That's probably related. Although, this is still just really fucking tiny. Like, what the fuck? I must be wrong that Zoom 1.0 must not be what I thought it was. I think that maybe we initially set the zoom. We set the zoom to be like the 1 over the width. I see. Because the zoom is the multiplier of how big in meters something is to how big it is on the screen. So we actually want to set the point size here in meters, which is really funny. The bus size this is actually like kind of weirdly in meters. Is that right? No, that doesn't sound right because 5 meters should be visible. This thing gets initialized to. Okay, let's look at the map. Vertex shader. We take the position of something, we multiply it by the zoom level. So the zoom level gets us from meters to screen space, right? So we want to see the whole map. The whole map is like 100 meters across. We multiply the zoom level to get it to be some number of screen space. So our point size. So as the zoom gets bigger, zoom level get bigger, distance between points amplified. Yes. So I don't know why I would have thought this is meters, but maybe it's not. It's no, it is. It is. So I just don't know why 5 is so small. What number do I want? Can we like std log debug just like self view state zoom? It is just really fucking small. Also, it's negative. That's kind of interesting. That's really interesting. I see. So that's probably why this wasn't working. Is we want to multiply this by like abs zoom? But the fact that it's negative is really fucking weird. It means that like when we calculated the like min and max bounds of our world, we like got it backwards, I guess. Okay, now can we see anything ever? Like okay, we do. It is growing with the zoom level. It's just not. It's just starting way too small. So 50 meters. We'll pretend that the bus stop is 50 meters big. Let's see. Am I fucking stupid? Even that's not working? Did I compile? I did. Like 100? Surely it must not be in meters then. Am I fucking losing my mind? 1,000? Why does it look like feel like it's not growing? Oh, it does. Oh yeah, okay, so my initial guess that this is in meters is just totally fucking wrong. 10,000? What is this unit? Okay, do I feel like these are staying consistently sized within the world? Yes, so here's kind of this corner is going up to the top just underneath that road. Yeah, I think that's staying consistent. It's just weird. I guess it's just what I want is probably not something that's tied to world size. But I guess that's fine. That doesn't feel too bad, I guess. They feel too big when I get too far in. We probably want to limit the point size. This is very confusing to me. I'm missing something like just overall about like all of these calculations. Right, so because we look over, it's the initial zoom level is 2 over the width of the entire fucking thing. So it must be, I wonder if like our unit is not meters in our coordinate space converter. We ran this stuff, which comes from like GPS coord to meters. Like we kind of stole this from Wikipedia somewhere. And I wonder if it's like just not to meters. Whoever said maybe it's centimeters, maybe it's millimeters, maybe you're right. Measure of meters per degree of latitude varies continuously with latitude. So the length of meters of a degree of latitude at latitude this is this. Okay. So this is like the formula we copied. The length in meters of a degree is this. That looks a lot like what we have. Minus 93.5 plus 0.118. So like, what the fuck? What am I missing? Stood log debug. Width of map. Meter metadata width. I know this doesn't matter, but this is like kind of one of those things where I think it's important to understand, like, if we don't understand the data and we don't understand why we wrote the bug the first time, then like we are bound to like hit more problems again in the future. So he thinks the width of the map is 121,000 meters. So 121 kilometers. That seems right to me. That seems right. I'm gonna look at this off screen. I think that it's possible that when I Google Maps, I can never remember if Google Maps like leaks my fucking location. It doesn't look like it is, so we're chilling. And so if I like just like say like measure distance from here to here, how do I? Oh, here. 121 kilometers is like really fucking far. like really far. Like that's this ish. So that's not right. That's not right. What the fuck is going on here? So this is the longitude step over the width in degrees. Which means that this step is just fucking wrong. Long step times width in degrees. Width in degrees is the maximum longitude minus the minimum longitude. So first of all, how the fuck is the width negative? Oh, because the step is negative. Okay, that lines up probably. No, even that doesn't match up. What is this formula? What the fuck is going on? Similar length of meters of a degree is this. Okay, this 111,412. 111,412 times cosine of phi. Cosine center line. Okay. Minus. Okay. 93.5 cosine 3 phi. Negative 93.5 times cosine 3 phi. Okay. Plus 0.118 cosine 5 phi. Plus 0.118 times cosine 5 times phi. Okay. Center ln could be negative. I think we're at negative 123. But that doesn't explain why this would ever be... Like, I would think that the length in meters to degree latitude is this, would make me think that this should always be positive? That would be my guess? Can we, like, fucking, like, hit the debugger? Zig out. Bins map. Okay, let's just fucking. Surely we don't understand something, so let's just like get into it. Let's get into it. He doesn't build because something. 32-bit int cannot represent all 64-bit values. Okay, sure. So it's in app.zig. It just happens that in WASM world, a U size is in fact a U32. But this needs to be cast. Here. In fucking whatever world we're in, 64-bit stream world. Or 64-bit stream, dude. I'm such a fucking streamer being like, everything is a stream. It's so fucking stupid. 64-bit integer world. Okay. Like, so what the fuck is going on here? Lawn step is a degree of longitude is 104,000 meters is what it thinks. 1 degree of longitude at 49th parallel. Is this like something that I can just Google? Like longitude 2-meter calculator online. Latitude, longitude, distance calculator. Latitude 49. Longitude 123. 49, 122. 7 kilometers. Oh my fucking god. Oh my fucking god. This coordinate conversion is just fucking wrong. Holy shit, I'm so fucking stupid. Oh my god, this is in degrees. Oh my god. Holy shit. Jesus Christ, dude. Rad per deg. Jeez Louise, that's bad. Holy shit. Holy shit. Breakpoint on fuck. Breakpoint on this thing. Nope. USB software, I'm gonna give you maybe like 30 seconds to say never mind, or else I'm going to respond to what you said, and when you say what I think you're gonna say, I'm gonna ban you. Okay? So we're giving you 30 seconds to say never mind, and then I'll follow through. But just so you know. Oh, I'm scared. Okay, who's Candace? Be a man. Oh, Jesus Christ. Okay. Candace needs to decay. Banned. And he's banned. Everyone, can we get some 07s in the chat for our fallen comrade? Candace nuts fit in my mouth. Wait, oh, there goes another one. I guess I don't really want to do bans. I want to do timeouts. I don't know how to unban people, so I guess USB software is gone forever. I'll try to unban him later, but you know, we never know. We never know if we're gonna figure it out. Okay, info locals. Banford D's nuts notes seems like too much. Yeah, but I mean, it's also my stream, so I can kind of do what I want. This still seems really fucking wrong, huh? This still seems really fucking wrong. Be a man versus exactly child. Love these individuals. Poor guy. Okay, let's. What do I want to do here even? I guess I did want to just breakpoint here and look at the things again. I did just want to look at the break here, run, info args, info locals. So we think that our center of longitude is negative 2.14, which seems kind of right. right? Vancouver longitude 123. 123 west, which is negative 123, which is about half of 360, or like 2/3 of 360. So 123 over 360 is about right. No? Oh, times pi. Times 2. Yeah, okay. Okay, so this is right. In which case, I'm still confused about why this is not giving me, like, I guess I want my lat step should be the step of 1 degree, I guess. If the width in meters is supposed to be my longitude step times the size in degrees, then this should actually be, I should be doing my long step is not like a singular point, but it should be a movement in points, which means that this should be 1 degree. Oh, but that's what this is. That's what this is supposed to be, right? This is supposed to be, this formula is to move 1 degree on the spheroid, blah, 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 the length in meters of a degree of latitude at latitude phi. That is the meters that you have to travel along the north-south line to move 1 degree in latitude when at latitude this. Okay, so this is right. That's right. So we are at this latitude. We're at latitude center lat. They say, and similarly, the length in meters of a degree of longitude can be calculated. So this is right. This is what I thought it was. Center longitude. So we are at longitude negative 123. And so our longitude step should be whatever the fuck that calculator told us. Longitude, latitude, 2 meters. Let's just double check that, like, convert coordinates. Let's try some. Okay, so latitude, we're at 49 lat negative 123 ish. And we want to convert to distance. We want to convert to distance. Where didn't we just have a fucking GPS coord 2 meters? We were just at a website that did this for us. Where the fuck did it go? Lat long distance calculator. Was this? Yeah, this is it. So coordinates are in degrees. So we wanted 49 negative 123, and we want to go to 49 negative 122. Right? Their distance is, oh, this is in meters. It's oh, Jesus Christ. They're using fucking British notation. So it's 72,000 meters. 72,000 meters. Is that what we're getting? No, what is this? 72,000 meters for what? For the fucking, we want to use our max and minimum longitude. What the fuck am I doing, dude? Holy, my brain's not fucking working today. Okay. Breakpoint here, run. Info locals. Print, let's print metadata. Oh, here. Okay. Info locals. So our width in degrees is 1.16. So if we fucking punch into this fucking calculator, negative 123 plus 1.16. So 1.123. So this is going to be 121.9. So we're looking at like about 80,000 in meters is what we want. So we want meter data, meter met data. Width in meters is 0. Fuck everything, fuck everything, fuck everything. Oh, wait, we're supposed to print it. We're supposed to print it. WASM. Zig build Python HTTP server. What do we say? It should be 80,000. That number looks familiar. But let's see. Refresh. 70,000? I don't know. I don't know. Also, I'm not gonna lie, this doesn't necessarily feel right. This feels stretched now. This definitely feels stretched vertically, which makes me think we've done something wrong. Again. So max lat minus lat. So we're kind of saying we want to go this far. Plot twist: the AI calculator is confidently wrong. That's possible. Okay, let's print. Let's print the max lon and min lon. Okay, and then we're also going to print the max lat and min lat. Wow, we're getting crazy. Okay, so meta, you know what? Okay, fuck this. Yeah, fine. I guess we have to. Metadata max lon max lat. This is sorry. Min lon and max lat min lon. Okay, we fucking got there. We got there. Now what? Calidio, thanks for the prime. Appreciate it. Appreciate it. Okay, let's fucking get my fucking thing open. So we're going from negative 122.3 to negative 123.4 at 49.47. We fucking got the other one on. Fuck. This is min lat. All right. So we are at like 49.2-ish. Right? Okay. 49.2. Not that I think this should make a big difference, but let's just see. 49.2. And we are trying to go from where the fuck we were just looking at. Negative 122.3. Okay. To negative 123.4. Copy paste this. Copy paste. He sees that this should be 87,000 meters. Live for love, peoples. Do you guys want to see fucking people making out and then be told that you should buy diamonds? Fucking ads, man. Like, what the fuck? So 87,000, which is just not the number we're getting. Like, at all. So, fuck me, I guess. Now the question. Now we just have to start debugging. Like we have to start bisecting whether we think it's our fault or their fault. So I'm gonna look at this one more time. One more time. So length in meters of a degree of longitude. So we have now a degree of longitude. Is this backwards? Something about this doesn't seem right. The fact that longitude is moving with longitude doesn't make any fucking sense to me. Maybe look up a new formula. Okay, like, I think that we should understand the formula that we have. Length, phi must be latitude for both of these. Oh my fucking god, I'm a dumbass. We don't need center lon anyway. This is center lat. Because, I guess they're saying that both of these things change with latitude. I bet you that's it. I bet you I'm just a fucking idiot. And I bet you this has just been wrong forever. 84,000? Nice. Okay, the map is upside down. Okay. But But the distance here looks way fucking better. 84,000 matches very closely with what we saw here. 87,000. That's close enough. Right? It's not like perfect, but we'll fucking shut the fuck up. Rs4, thanks for the prime. Or not prime. Sub. Thank you. Thank you. That's way better. Okay, and then also, like, it was bothering me too. The projection didn't seem right when I was looking at satellite data before. So I think it's important. Like, I think that this looks way more reasonably shaped. I think, right? Like, downtown looks pretty like square now. When I feel like it looked kind of like parallelogrammy before. Now, why the fuck is this flip now? That's not good. So somewhere we're flipping something that we shouldn't be. I just don't know what. I don't know what we should be flipping. Let's go to app.zig. Let's print the height as well. Negative positive somewhere. Dude, this guy's a genius. Yes, I do think it's a negative positive somewhere. I just don't know where I think the problem is. So the height and width are both positive, so that's good. That means that probably it's in our vertex shader. What are we doing? In our vertex shader, the y is times the aspect times the zoom. So everything here should be positive. We set the center correctly, and if I go up, interestingly, this is kind of scale, like we're kind of moving, like it's not moving with the mouse, which is kind of a clue about something. But it is moving in the right direction, which is kind of surprising to me. That's surprising. I would also expect it to move. If it's moving 2 times as fast as it should, then that's a good clue about something as well. Which it might be. It might be. Is our, like, lookup? He's also finding the right street, which is kind of interesting. Okay. So we could think about coordinate spaces here. In our world, the larger latitude should be higher, like on the screen, right? Because I'm in the northern hemisphere, so the bigger the number gets, I guess no matter what. I mean, if the center of the Earth is 0, anywhere you go, if you're negative numbers, the more negative one should be lower on the screen. If you're going up, the more positive number should be at the top of the screen. So I think that makes sense. Both of those line up. So, am I inverting y somewhere like a fucking dumbass? Coordinate converter. Where are we doing our, like, map data? Coordinate space converter. So when we say somewhere that I want to get my meters, we are doing longitude minus min-lon, but here we're doing max lat minus lat, which is kind of silly. Lat minus self, what was it? Self metadata min lat. I think that we had this at some point, then it ended up upside down, so we just kind of flipped it. And this is the problem with just kind of like doing stuff without thinking about it. Is I think that we convinced ourselves that that was correct before, and I think it's just not. Hell yeah. Okay. That feels better. I don't even remember how we ended up looking at this stuff, to be honest. I don't remember. And then I want to know if the mouse coordinate space moving, it feels like it's not tracking. So I want to look at on mouse move. All this math without unit test, that's risk. Dude, there's so much to think about in what you just said. Okay, so let's do 1.0 over, because that 2.0 was probably just like compensating for a mistake somewhere, probably. We can see though. Now vertically, oh, it's slot tracking. Okay, that 2.0 is for both X and Y. So get movement. The movement, we are saying that we have normalized X and Y. Where do these normalized things come from? Index.js. This, we say on mouse move. We get the mouse move norm Y. I think that it's just that everything should be scaled according to width. I think it's that everything is scaled according to width. So the mouse movement should also be scaled according to width. And then maybe this will kind of... that feels a lot better. That feels pretty good. So if I hold, like, right in the center of this thing, that's staying kind of where my mouse is. All right, there we go. Okay, that's a lot of fixes. Now, I also want to look at the satellite data here, since we're here, because it looked fucked up to me before. And so I want to know if it doesn't look fucked up to me. So I think we can fix... Here, output JSON. Let's just do this. RM this, go back like this. I want to paste it, because every once in a while I accidentally overwrite that. I think there's like a bug in like make site, where if I run it without asking for satellite data, it overwrites the existing satellite data. So I need to fix that, but instead of fixing it, I just copy paste the file so I don't forget. One day we're gonna lose all the satellite data and it's gonna piss me the fuck off, but not right now. So, well, maybe right now. We actually don't know. maybe this will piss me off right now, and that'll be kind of a fun little exercise. Okay, okay, so wasm Python, run the fucking server, please. I want to fucking run my HTTP server, please, sir. Where's my satellite data? Refresh. There we go. Here we go, baby. He's gonna load it really fucking slowly. Like, actually, like, way slower than I think he should, but that's okay. Oh, dude, those look so much better. I don't know why it's so slow. Maybe it's because it's like logging a bunch of stuff that it shouldn't, and also because the console is open. Hold on. Everything is flipped now. All of these tiles are flipped, so we need to fix that. So it'll be an app zig. And somewhere we're just fucking flipping the... Oh, I remember this. We flipped the tiles, and that it was right. Then we did the conversion to meters, and then it was flipped again. So we just unflipped it like fucking idiots. And so this explains another bug, like that we shouldn't have just fucking blindly ignored. Because this we thought that this should be like this. Because the image space is supposed to be inverted from OpenGL space. Because in OpenGL, I think that the bottom is higher in Y, and the bottom is 0 in Y, and the top is 1 in Y. But in image space, 0 is the top and 1 is the bottom. So, like, it makes sense that it was broken. There we go. That's following the coastline a lot better. And I wonder if this fixes the fact that the tiles weren't lined up right? Because we were seeing seams on the tiles before as well. These look lined up way fucking better. Dude, we just fixed so much. That's so sick. And then downtown looks like kind of okay. And now, also, do I think that these dots are too big now? Do I think that? But yeah, look at this. Okay, so I wonder if I can show what it looked like before. I think I can. I think if we, git stash. Let's see. I don't know if this is going to get fucked up in some other ways, but here if we refresh, let's see if we... No, he's mad about something. Unreachable executed. Okay, it was fine. We can make site. Give it a sec. Remove everything with committing or stashing, dude. I guess it wouldn't take too long to read everything we did today, so it wouldn't be the end of the world, but it wouldn't be great. I shouldn't have ignored. I remember seeing this before and thinking that there was a problem actually because of this, and I should never ignore stuff. Never ignore, always don't ignore. All right. Yeah. So this is what it looked like before, and I remember thinking, like, it just looks fucked up. It just looks kind of, like, weirdly warped and, like, squished vertically, right? You can kind of see that, right? Where, like, all of these diagonal buildings just look like they're too short, right? It's kind of like, ugh. And if we get stash pop, we can actually open this second version in a second pane, and then we can compare. We can compare. Wow, I have a lot of tabs open. Collie got his car stolen from his Collie got his car stolen from his laptop. That's not what you said, but that's what I read. Collie got his laptop stolen from his car, didn't push for 3 days. You know, I honestly think that if you don't push for like a week, you only really lose. Fuck! I didn't mean to refresh that. That's annoying. You only lose like a day of work. Which isn't that bad. See, this stuff looks like way less like squished now. I would argue that maybe it looks like a little too tall, but you can kind of see it like the building is kind of like lined up now. It looked like really stretched and skewed before, yeah. And now it looks. Now I'm like not convinced because I'm like kind of like paranoid about it. But I think that these buildings just are long buildings and they're like kind of correct now. So it's pretty sick. And the seams also in like the tile map, they're still not perfect, I guess. That's kind of weird. So I guess those aren't like perfectly fixed, but all right. All right. Okay, so that really distracted me from what I was trying to fix. But I mean, I think that's like a big win for us. What were we even trying to do before this? I don't even remember. Oh, we were trying to. This came from the fact that we were trying to guess the size of the bus stop. Oh, that's so funny. We were trying to guess the size that we thought that these bus stops should be, and we were like, why the fuck am I typing 10,000 here? So we can go back to that and see if we can like infer a little bit more about like what we expect. Like if we can guess a little better now. That's really funny. So bus point size. We think that at zoom level. Right. So here we log the zoom level. So let's so when we were zoomed kind of like here, zoom level is like 0.002. So this makes sense. Zoom level is now getting bigger in number as we get closer, which is great. And now we can kind of say like zoom level 1.0. What does that like mean to us? What are we at now? We're at zoom level 0.09. Okay. I want to stay scrolled to the bottom. Okay. So let's like try to look at like a house, right? And now we can kind of say that like zoom level 0.2 is about the width of a house. I wonder, do we think a house, how wide do we think a house is? House width in meters. Length of 12.8 meters and width of 35 feet or 10.67 meters. So that actually lines up here, right? If we fill this up here, this is 0.2, right? And if you do 1 over 0.2, that's 5. But the OpenGL coordinate space is 2 times too big. It's -1 to 1 instead of 0 to 1. So this actually like 0.2 mapping to 10 does make sense to me. That makes sense. So that means that the zoom level I think is just 2 times what it should be. So now I don't understand this 10,000 thing still for the point size. This is how many pixels we think should be taken up at a given zoom level. Or something. So this is like pixels at zoom level. Zoom level is equal to 1 over meters. Is that correct? 2 over meters? So zoom level of 1.0, we think we should see 1 meter for the whole width. So here we want the pixel size to be like, as zoom level grows, we want the pixel size to grow, which means that the pixel size is inversely proportional to meters or something. In a full dataset, there are actually geometries and stop areas for the GeoJSON. Yeah. We have. Oh, for the stops. I was looking at the geometry of the. I was looking at. We do have shapes in here. I wonder if the stops have shapes. There's nothing here that indicates that it says that. But also I just want to draw those points. But that's interesting. That is interesting. So I'm just trying to see if I can math out right now what I think this number represents. So we know that the dist between points times zoom level is what we map on the screen. We think that zoom level starts as zooms equal to 2.0 over the meter rounded to width. Okay, yes, this makes sense. So this is like its initial value is like really small number as scalar between points to try to make them fit on the screen. So we're trying to make it so that the whole map fits in 2 meters, which means that this, if we want the bus size, stop size to be like, I'm still a misunderstanding. I still don't understand why this is so large. This is like some weird like pixel times meter space maybe? Like what the fuck is this unit? We have zoom level is in units of at 1.0 at zoom level 1.0. Okay, at zoom level, our zoom level starts as 2.0 over width in meters. This is, I'm sure that we can figure out what these units are. So I guess this is just like, and this 2.0 is the screen size? Screen space. So zoom level being screen space per meter makes sense. So as we zoom in, we get less screen space per meter, more screen space per meter. Yes, which matches up. Size get bigger, thing get bigger. So our point size is in pixels, which is different than screen space. We have like 1024. What's like a resolution? 1920 by 1080 pixels. So is like the resolution, right? Okay, I think I'm getting there. So we have like 1920 pixels per screen width, and our zoom level is in screen widths per meter, approximately, times 2. So that explains why this has to be so fucking big. Does it? So if we have 1920 pixels ish, but this is probably more like 1,000. Our unit is like pixels per meter. But that's not constant. That's not constant. 1,000 pixels per screen width. That's true. And our zoom level is like screen. I think I'm like a little bit off on the units here. As this gets bigger, we get more screens per meter. Okay, sure. Screens per meter constant. And zoom is C. And so our zoom level is usually really small. So we're trying to get like, as the zoom level increases, this constant, yeah, so this is like A times C, this is like point size times zoom levels, which is screens per meter to pixels. Yeah, okay, I think I understand. I'm not like 100% there. I can't like articulate it well enough, which means I can't say I'm understanding it well enough. But this big ass number is making sense to me when I kind of lay it out this way. So zoom level, this is small as shit, right? Which means that this has to be big as shit. That that lines up to me. That lines up to me. Okay, sure. Okay, okay. I think we got there. We got there. Now, are we everywhere? Does everything good and make sense? Maybe not, but we did manage to make a huge improvement on our coordinate space mapping. We now are mapping bus routes. I was hoping at the beginning of the stream, I was hoping that we would get to the point where I could hover over these bus routes and it would tell me which route this is associated with. We never got there because we got super distracted by like coordinate spaces and stuff. But I think that was a worthwhile endeavor. So I think we call it there for today. I think that probably we're at a point where I probably will try to merge this bus route stuff. And so I think this is like kind of like a good checkpoint. It's not perfect, but we can kind of call this like one feature. If you guys were my product managers and it was end of sprint, I would pretend that I finished a ticket. I would just call the ticket something different, but I would pretend I finished it. So happy with that. Happy with that. Okay, yeah, we'll call it there for today. So thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to around 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so around, half an hour, or sorry, around like 4 hours ago now. If you're new on Twitch, there's a YouTube link in the Twitch description where you will see playlists for all of the things that we've worked on. We are working on this map right now. We've done a bunch of other stuff if you want to check that out. There's a GitHub link in the Twitch description where eventually end up under this FMAP repo. If you're watching on YouTube, there's a Twitch link in the YouTube description where you can swing by and say hi if you're online between the 12 to 4 Pacific time times. What else? Like, subscribe, Twitch Prime. There's a Discord link in the Twitch description. Yeah, I think that's all we gotta talk about. Sorry, brain's melting. So, YouTube, goodbye, and Twitch, let's find someone's raid.